Understanding port channels and what it does is pretty simple. It is a technology that allows you to bundle multiple Ethernet interfaces together into one logical connection. This logical connection is called a port channel or an Ether channel. This could be a port channel to a switch, maybe a router, or even to a server. You can bundle up to 8 or 16 Ethernet ports in a single port channel connection depending on what negotiation protocol is set up. Using a port channel can increase the bandwidth for a connection because, again, multiple interfaces are grouped together. So for example, if you bundle two 10 gig interfaces together to another switch, it will be a 20 gigabit connection. It's also important to understand that this is not really a 20 gig connection. In reality, traffic is being load balanced across all interfaces that are bundled together. It will load balance based on what algorithm is defined. It can be load balanced based on the source IP, MAC address, or port number. Maybe the destination IP, destination MAC address, or port number. Or the source and destination IP, MAC address, or port number. Now, what's supported depends on the switch hardware and the OS version that is used. So from the list above, using the source destination port algorithm is recommended to be used if it is supported. On Nexus switches, the default load balancing algorithm is based on source destination MAC. So just keep those factors in mind. To use port channels, there are two types of negotiation protocols or encapsulations that can be configured. There is PAGP and there is LACP. Or you can statically build the port channel without any negotiation. So a static port channel is typically not recommended for data center environments since it is not doing any kind of monitoring or using keep alive messages for reporting its health. Furthermore, it only supports up to 8 Ethernet ports in a single port channel, so there are some limitations. PAGP is a Cisco-based protocol that was available long before LACP was around, so it was supported by IEEE. But LACP, or 802.3ad, it was later passed by IEEE as an open industry standard to be used for port channel connections that networking vendors can follow for implementation. Furthermore, LACP supports up to 16 Ethernet ports in a single port channel. So from these three, LACP is the recommended encapsulation to use because of its industry standard support. So for example, if you want to set up a port channel between a switch and to a server, then LACP will be required for the configuration, similar to how 802.1q is recommended over ISL for the trunking encapsulation. Another component that is important to understand about port channels is the mode and how it is configured between the devices. Let's focus on LACP since that is the recommended protocol to use. So you can configure port channel ports on a switch to be either in active mode or passive mode. In active mode, the switch will send out special frames to the other connected device that it wants to build a port channel using LACP. So if the other end is configured as a port channel, then the connection between the devices will come up. So the connected device, it must be configured for either active or passive mode. Passive mode means that the device will only listen for LACP messages. It will only enable LACP or bring up the port channel if the other device initiates the connection. This means that the other end must be enabled to use active mode for its port channel ports. So as a safe bet and as a best practice among your critical devices, you should set the port channel mode to be active on both ends. A port channel that you configure will either be a layer 2 port channel or a layer 3 port channel. A layer 2 port channel is a switch port enabled interface that can support VLANs and 802.1q trunking. This can be configured with ports on F or M series line modules. A layer 3 port channel is a routed interface where you can configure an IP address to be part of your routing domain. Now, since this is dealing with layer 3 services, it is only supported with ports on M-series line modules. If you attempt to configure a layer 3 port channel on ports on a F-series line module, you will get an error about compatibility failures. So just keep that in mind. Layer 3 services pertains to M-series modules only. There are other requirements to keep in mind if you are configuring a port channel connection between two devices. Number 1, the speed and the duplex on all ports that will be bundled together must be the same. Otherwise, the port channel will not come up. You want to be consistent. The type of port that is used must also be the same, whether it is a layer 2 port or a layer 3 port. That must be the same, or once again, you will get an error about compatibility. Furthermore, the port channel interfaces that will be bundled together must use the same I/O module type, whether they are F-series or M-series modules. This is once again comes down to whether it's a layer 2 or a layer 3 port channel. The identification number that you can use for the port channel interface, now that doesn't have to match between the two devices. However, it's recommended to keep everything consistent and organized. Use the same ID between the devices. And of course, once again, you can only bundle up to 16 Ethernet ports for a single port channel connection if you're using LACP. So that is a brief understanding of port channels and how they can be used. In our environment, this is how we will be configuring port channels to our uplink and downlink interfaces based on data center best practices. For all of the interface connections between our data center switches, we will bundle them together as a port channel, which is seen here in this picture. Now, these are 10 gigabit interfaces, and they will be bundled together as a single logical 20 gig interface. Below is a list of the port channel interfaces that will be configured on each switch. So as you will see, each port channel interface ID, these right here, will be based on the device ID for easy identification. So for example, let's go back for a quick second. So we have two 10 gigabit interfaces connected between DC1 and DC8-1. So this will be configured as a port channel using port channel ID 13, which is reflected here. And this is listed right here. So that 13 right here, this comes from the device ID for the two devices that this port channel will be connected between. So the 1 right here, the 1 is for DC1 and the 3 is for DCA1. This means that if we see this port channel interface anywhere, we will know that this is for a port channel between DC1 and DCA1. Furthermore, these port channels will be layer 2 port channels, which means that they can be configured for single VLAN or for trunking. Now, in our case, since we need to extend multiple VLAN tags, these layer 2 port channels will be configured for trunking. Now, for the port channel encapsulation, we will use LACP, which is recommended, and we will also enable LACP fast hello timers on these interfaces. So those are the details for how we'll be configuring the several layer 2 port channels between our switches in our environment. Let's start our configuration for our port channels. Now, what I would do first is I will manually configure a layer 2 port channel for the two interfaces that connect down to DCA1. For the other port channels, I have prepared that configuration to save time because it is a lot of redundant configuration. We want to save time. Okay, so first things first, we will need to enable the LACP feature, and this will be the negotiation protocol that we will use for all of our port channel connections on our network. Next, we will create a unique port channel interface and identifier. So let's go ahead and do that. Say port channel 13. And again, the 13 comes from the device ID for the two devices that this port channel will be connected between. Okay, moving ahead, we'll go ahead and put in a useful description for what this interface does. It's always useful to do that. So again, this is a port channel from DC1 down to DCA1. Next, we will enable this port channel to be a layer 2 port channel. Okay, next, similar to what we configured on the individual interfaces earlier, we will specify the native VLAN of 999. Okay, and this port channel will be enabled for 802.1q trunking. Mode trunk. And we will configure trunk security, allowing only our server VLAN tags across this port channel. Okay, and finally, let's enable this port channel. And let's go ahead and exit out here. Now, the next thing that we need to do is we need to associate this port channel to the physical interfaces that will connect down to DCA1 based on our design. So we'll first specify the range of interfaces that connect down to DCA1. Okay, next, as a best practice, we will enable something called LACP rate fast. When a port channel is formed, it will establish a relationship with the other device. Now, if the port channel is built using LACP, it will send hello messages, which are like keep alive messages, to ensure that the port channel is active. Now, we can control the rate of how often the hello messages are sent. By default, the hello messages are sent every 30 seconds. So enabling the feature LACP rate fast, it will change the hello message interval to every second, providing faster convergence and negotiation for the port channel connection. Moving on with our configuration, we will enable these interfaces as layer 2 interfaces since the port channel is also layer 2. Otherwise, we will get an error. Next, we will enable these ports as trunking ports. Mode trunk. And then we will associate our port channel interface or group to these interfaces in active mode. Great, and now this end on DC1 is configured as a port channel. So the other end on DCA1 would need to be configured the same in order for this port channel to come up between them. Before we do that, let's configure the other port channels on DC1. We will configure a port channel that goes over to DCC2 and a port channel down to DCA2. As I mentioned before, I have prepared the actual configuration that we need to apply. It is exactly the same as we did earlier, but with different port channel IDs and interfaces, of course, based on our design. So for the first part right here, this is the configuration for building a layer 2 port channel to DCA2. And it will use a identifier of 14 based on our device ID schema that we talked about earlier. And this port channel will be associated to the interfaces that connect down to that switch. Therefore, let's go ahead and copy this first part of the configuration and let's paste it into our core switch. Okay, so now let's go ahead and go back to our configuration notes. And for the second part right here, this will build a port channel to our secondary core switch. Now this will use a different port channel ID and interfaces once more based on our topology. So let's go ahead and copy the second part of this configuration. And again, this will be built to our port channel to DCC2, which is right here. So let's go ahead and apply that configuration. Now let's configure our 3 port channels on DCC2, and this will be very similar to what we did on DCC1. So let's first enable the LACP feature. Next, I have prepared the port channel configuration that we need to apply to DC2. And the first part will build a port channel down to DCA1 using an identifier of 23. and of course the appropriate interfaces that connects to DCA1. So let's go ahead and copy this configuration and let's paste this into our switch. Great. Let's go back to our configuration notes, and here we are. And this config here will build a layer 2 port channel down to the other access switch, DCA2. So let's go ahead and copy all of this, and let's go ahead and paste it into our switch. Okay, and finally, let's go back to our config notes. This configuration here will build a layer 2 port channel over to DC1, which is already configured for its port channel interface. So once more, let's go ahead and copy all of this configuration and let's paste it into our switch. At this time, the port channel between the two core switches should be up and working. Let's confirm that by issuing the command, let's exit out here, show interface port channel 12. And there we see that the port channel interface itself is up, which is reflected here and here, and that this is a layer 2 trunking interface, which is reflected by the port mode, which is trunk. Using this same command, you can even see the members or which interfaces are associated to this port channel. And it says Ethernet 19 and 110. These are member interfaces associated to this port channel group. We can run other port channel commands for validation, but let's first complete the other port channels on our access switches. So let's go to DCA1 and let's first enable the LACP feature. Next, here's the port channel configuration I have prepared for DCA1, and its first part will build a port channel up to DC1. So let's go ahead and copy this configuration and paste it into our access switch. All right, here. Okay, let's go back to our notes. And this configuration part will build a layer 2 port channel up to DC2. So once more, let's go ahead and copy all of this and paste it into our access switch. Lastly, let's go to DCA2 and let's enable the LACP feature. Next, here's the port channel configuration I have prepared for DCA2, and its first part will build a port channel up to DC1. So let's go ahead and copy this configuration and paste it into our second access switch. Okay, let's go back to our configuration notes. And this configuration will build a layer 2 port channel up to DC2. So let's copy this configuration and let's go ahead and apply it to our switch. We are now finished building all of our port channel connections between our data center switches. Let's confirm that all of these port channels are up and working. Let's go to DC1. And really, the best command to view all port channels that are configured on a switch is the following command, which is, let's exit out here. And that command will be show port channel summary. It's a good command. So this here will show a great summary of our port channels, the member ports, and the protocol that is used. So looking at the first line right here, you will see that on DC1, we know that based on our device ID schema, port channel 12 is a port channel between DC1 and DC2. You will see two flag IDs. You will see an S and a U. Now the S here means that this is a layer 2 port channel, and the U means that this port channel is up with more than one member interface being operational. Now the actual member ports or interfaces that are associated to port channel 12 are right here. It is Ethernet 19 and Ethernet 110, which are connected over to DC2. Now the flag ID of P that you see here, this means that this member interface is up and operational. Therefore, the port channel between our core switches is operational. So you will see the same thing for the other port channels that we have built down to our 2-axis switches. They were all up and running. Now for the protocol or the negotiation protocol, these port channels are using LACP, which is what we enabled globally on all of our switches. Now let's confirm if the port channels are up and running on DC2. We should see basically the same kind of details. So we'll do show port channel summary. Okay, and there we see the same thing. We see our port channels and the member ports are all operational with the correct flags. SU, S4, that these are layer 2 port channels. U means that these port channels are up. And for the member interfaces, they all reflect a P, which means that they are up in the port channel. Let's do the same on DCA1, our first axis switch. Let's exit out and let's do show port channel summary. Okay, and this will show our 2 port channels that they are up and operational, connected up to the core layer. And lastly, let's do the same on DCA2. Let's exit out here. Okay, and again, those port channels up to the core layer and its member ports are all operational. Another command that you can use, let's go back to DC1. Another command that we can use is a command like show LACP neighbor interface, let's say port channel 12. This will show the 2 interfaces that are in this port channel group on the other switch. In this case, these are the interfaces from DC2. Now over here on the right, you see partner flags, an F and an A. So the A means that LACP active mode is enabled on the other side, and the F means that fast hello timers are also enabled. So you can treat this command similar to the CDP neighbors command, as this will show details for how a connected device is configured for a port channel. Another thing to monitor is to confirm if traffic is being load balanced across our port channel connections. So right now we have some basic data transfer occurring between our servers, like a copy and paste. And based on our topology right now, let's go ahead and bring that up, without any span tree changes, which we will do in the next step, the traffic flow is really like this. So traffic flow from server 1 to server 2. Server 1, traffic is going up to DCA1, up to DC1, down to DCA2, and then the server. And of course, vice versa for the return path. Therefore, let's view our port channel 13 interface that is between DC1 and DCA2. Okay, and there we see the port members in this port channel interface, or in this port channel group, which is once more reflected right here. Members in this channel, Ethernet 211 and 212. These are the physical interfaces that connects down to DCA1. We also see in a 30-second and 300-second interval the amount of traffic across this port channel in terms of inbound traffic and outbound traffic. Now we can specify and maybe view just, let's say, the output rate details. Let's do that. And let's do it a couple of times. So here you can kind of see that kind of traffic rate. Now these numbers aren't changing because the interval is only every 30 seconds and 300 seconds. So if you wait like 60 seconds or something like that, then these numbers here will change. Now, if we want to confirm if both member ports in that port channel is indeed in use, traffic coming inbound and outbound, we can view the output traffic for, let's say, the first interface. So to do that, we'll do show interface Ethernet. And find the port information is 2/11. And let's look only at the output rate as an example. Okay, so there we do see some traffic, outbound traffic. And let's do the same for the other port in this port channel, which is port 12. Okay, and there we do see traffic also. So traffic between our servers are being load balanced across this port channel. We can, of course, run the same commands on the other access switches in our topology to view very similar details. So again, this is really a good kind of confirmation of how can you view some kind of traffic activity that could be happening. So that will conclude what is needed for setting up our layer 2 port channels in our environment and how you can monitor some of the behavior.